Hi everyone, welcome to the video. Today we are going to solve is that a tree. In this question we are given n number of nodes and m number of edges, and these are those edges. We have to return whether this particular graph is a tree or not. So as we go ahead with the bookish definition, a tree is a graph, a graph is a tree if it meets two conditions. First, it has no cycle. Second, all the nodes are connected. The graph is connected. So we'll check for both these conditions. If they are true, well and good. If they are not, then it's not probably a tree. So first of all, I'll create uh, an adjacency list. I've created it. Now I will populate it since edges is the the graph, the adjacency graph which are given to her here. Now I will append them in an adjacency format. Okay. Now that I have populated it using the edges which are just given over here, so I'll create an empty set visited with and a list queue which will have two elements, the current element and the previous vertex, current vertex and previous vertex. Since we are starting with the zero first element, it has no previous vertex, hence -1. Okay, now we get two conditions. Either we can use BFS so that we can stuff from the right side and pop the elements from the left side, or the DFS where we stuff and pop out the elements from both from the right side, but eventually we'll have to pop out all the elements. So using any particular set of BFS or DFS may not help that much. So for this question I'm using a DFS. Okay, first of all I'll store it, pop one element from the queue and add it to the visited list. Now I will go for all the neighbors of the P, for all the neighbors of the P. If this neighbor is not visited, if this neighbor is not already visited, then add it to the queue neighbor and its previous vertex P0 since it is its parent. Okay. Now, if it is visited, means if the neighbor is already visited and it is not the parent node. Okay. So if we are checking a condition that if this neighbor is already visited and it is not the parent, okay, not the parent node, then clearly it indicates that we have reached a cycle. And if we have reached a cycle, there's no way this graph is a tree. We will return 0. 0 means this is not a tree, it is a graph only. Now second condition to check whether yes this graph is connected or not. So we will check two conditions: n is the number of nodes and visited. If the number of visited elements is same as number of nodes, which means we have visited all the nodes, well and good, we have found a tree, return 1. If that's not the case, no, we have not found a tree, it is a graph only, will return 0. Let me submit it for you. Okay, 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 I did a mistake. I used a colon over there. My bad. Let me submit it again. Yeah, this time it did the job. It did the job in pretty less time. So I hope you enjoyed it. I learned a new concept today. Thank you. Have a nice day.